Made a mistake last night. Maybe I can make it right. Slide on closer, baby. We can talk about it. No need to be mad. Hate to see you sad. Yes, I know I'm crazy, crazy about you, crazy about your love. I know I'm a flirt sometimes. I know I get drunk some nights. I know I get way too high. I just wanna live it up with you. I know that it might be tough. I know when you've had enough. It's just how I show my love. Darling, can I live it up with you?
All right, hello, everybody. How's everybody doing tonight? How's everybody doing this fine evening? Hopefully, everybody is doing well. Good evening to everyone. Hopefully, you're all doing great. Hopefully, you're here for another rip-roaring session of Math 102. Good to see everybody again. All right. Hopefully, everybody's doing great. We just got a little bit to do today, but let's stretch that out. We got a little bit to do today, but not too big of a deal. Should be pretty easy, pretty straightforward. At least I would hope so. Question mark. Okay, we'll get started here in just a few minutes, and then we'll get going here, ladies and gentlemen. We will get going here. I know some people come in a little bit later, so that's perfectly fine, and we'll get going. Alrighty. Make sure I have everything ready to go. Be helpful. Okay. Good stuff. Good stuff. Go. Got everything set to go. Just another minute or so, and then we'll get going. Just another minute or so, we'll get going here. Get you guys. Today's section is not super long, so should get out pretty early here today. Got out pretty early in the first class, so hopefully the second class will go over okay. Okay, let's move that to 7. Alright. Okay. Well, let's get going here. We'll hopefully have other people start to follow in. That's perfectly fine. Let's get going here. Let's do some intros, and let's get started, alright? Okay, let's do it. Okay, let's get started with today. Welcome back. Welcome back, everybody, to Tuesday. Hopefully on this weekend. Alright, so for today, ladies and gentlemen, we are going to be continuing moving forward here in Chapter 4. Last time, we talked about the correlation coefficient R, okay? And that was, again, a number that allowed us to go ahead and see, exactly what kind of relationship we had between two things, X and Y. And we also took a look at, say, hey, exactly how strong a relationship do we have between X and Y? Do we have a strong relationship? Do we have a moderately strong relationship? Is it a positive or negative relationship, for example? And we also saw, hey, depending on the sample size, do we indeed have a linear relationship between X and Y, whatever X and Y are within the context? Now, what we're going to do here today is we're going to take it one step further than that, okay? So we want to say, okay, let's say there is a linear relationship between X and Y, whatever the context says. Okay, well, what's the best model to reflect that linear relationship? That's essentially what we're going to be looking at here today. So, let's go to the big board here, and let's see exactly what we're looking at. Okay, now, let's go ahead and take a look here. Let me go ahead and take a look here. First and foremost, we'll get to that example here in just a moment. For today, we're going to take a look at questions 7, 8, and 9 on the handout from last time. And that is question 7 here says, how do we know to find the line of best fit? Now, this is what we're going to focus on here today. This model that will reflect the data set here, if there's a linear relationship between X and Y, we want to find what's called the line of best fit. Now, this is also called, I call it the line of best fit, but this is also called the regression line in a more formal context. So just a fancy way of saying line of best fit. Now, I like to call it line of best fit because it is the line that best fits the data set as best as possible. It doesn't go through every point, but it goes, it's basically like the average between all the points in some given data set. Now, as you can see here, all lines, as we know here in mathematics, are all of the form of y equals mx plus b. M, as you know here, is the slope. Okay, so as we know it, that to be the slope, okay, how do we figure out the slope here? Again, that's equal to r. Again, we factor in r that we talked about here before. And we want to multiply that by sy, again, the standard deviation for the y's, divided by the standard deviations for the x's. All right, now we also have b, which is, again, reflective of the y-intercept. Again, that uses the slope here in this case. So if you notice here, you have to find the slope first using the correlation coefficient and the standard deviations for the x's and y's, and then you can apply that to find the y-intercept, okay, if you want to find it by hand. Now, of course, in our case, we're not going to actually find it by hand. It would take quite a longer amount of time to do. What we want to do, of course, effectively, is to find this, of course, and be able to apply it and to see what it means within the context of that problem. So again, what we're going to see here today is we're going to see again the slope here. Again, that's the rate of change, and the y-intercept. Remember the y-intercept as terms of a generic point of view. Again, if we're going to interpret the slope and y-intercept, again, the y-intercept is if x is equal to 0. All right, this will prove to be important here in just a little bit. But let's take a look at an example here, first and foremost. All right, I'm going to kind of reverse these around here. I do need to write stuff down. Okay, so here what we see is, let's go ahead and read number 17. Now, number 17 is a problem that we actually worked on last time in the previous section. So we're going to work on this same similar problem here. All right, but let's go ahead and read this off here. Again, we have a data set that indicates the commute times, which is x, and the index and the score of a well-being survey, again, here on the right. Okay, now let's go ahead and look at letter A. Letter A says, find the least squares regression line, i.e. the line of best fit, treating the commute time x as the explanatory variable and the index score y as the response variable. Okay, so we're trying to find the line of best fit here in order to make sure that we get this thing to work. All right, so for us, in order to do that here, let's go ahead and start this off here. Let's go ahead and take out our calculator. All right, let's take out our calculator here. Now, make sure you have your calculator in front of you. All right, please type got it in the chat if you have your calculator out in front of you. I want to make sure everybody's on the same page because we're doing button presses. So type got it in the chat once you have your calculator out in front of you, and we'll go ahead and get started. All right, so Bill and Maritza are here. Let's say got it, good. All right, Sammy and Strolling, good. All right. See who else has their calculator. If anybody else is going to participate. Otherwise, I will move forward. All right. Well, maybe somebody will try me last minute, but in any case, we'll go with you guys. All right. So we all have our calculators out. Let's go ahead and see what we need to do here for our proper button presses. All right. First things first, let's go ahead and hit the stat key here together. And we'll go to edit, that very first option there. Okay. Now, again, if you have stuff here in your from your previous list, go ahead and let's clear them out. I know what I have here is already what we need, but still, let's clear out. Again, highlight the list, hit clear, hit enter. Okay, so that'll clear out the list appropriately. All right, so for list number 1, we want to go ahead and enter in the commute time here. So, again, all the x values. Let's put that in here. Just like so. List number 2, we'll go ahead and enter in all the index scores that are on the right here on this table. Okay. All right, so when everybody's got all the numbers entered into the calculator, please type out chocolate. All right, type chocolate in the chat once you have all the numbers entered into your calculator. Alright, so Strolling and Maritza. It's Bill and Sammy. We're just waiting on you. Make sure you have your numbers in your calculator. Alright, Bill's good. Alright, Sammy. See if you have there. Alright, Sammy says chocolate. Excellent. Alright, so now everybody has their numbers entered in the calculator. Excellente. Alright, let's move forward. Let's go ahead and hit the second key, and the mode key. This will just net us back, quit out to the main screen, making sure we don't enter any wrong numbers, of course. Alright, so what we need to do next here is we're going to need to hit the stat key. I'm going to go over to calc. I'm going to type this in chat here. So hit the stat key, go to calc, and then I'm back for one more, Dylan. Back for one more. We're going to go into linreg ax plus b. Watch some 8 out of 10 cats. That's a good show, man. That's a good show. I love Jimmy Carr. He's a good dude. Outside of dodging Texas, but you know. So we're gonna hit the stat key, go to calc, and then go down to number 4, which is linreg ax plus b. Yeah, you can't match Jimmy Carr's laugh. That's true. I've watched so many YouTube videos of 8 out of 10 cats, and 8 out of 10 cats does countdown. It's unbelievable. So I'm gonna miss Sean Locke a lot. I ain't gonna lie. Sean Locke is a legend. All right. So we have here we have the stat key. Go to calc. Go to linreg ax plus c. Now, if you have the old school calculator here, what you want to do is you want to go to linreg a. You'll see linreg ax plus b. You want L1 comma L2. So you want to hit the second key, the number 1 key, the comma key second, and the 2 key for L1 comma L2 if you have the old school calculator. If you have the new school calculator like I have, like you can see up here on the screen, again, you'll have your X list here to be L1. If there's nothing there for some reason, hit second and 1 for L1 to show up. If you have your Y list and nothing is there for some reason, you hit second and 2. These should automatically default to L1 and L2, but just in case if nothing is there, there you go, that's what you do. Frequency list and store, just skip these. You are not going to put anything in them. Make sure they are blank. Okay, put nothing in those. And then we want to go down to calculate. All right. All right, so this is what should appear here on your screen. Okay, if you get these same numbers here to appear on your screen, type countdown in the chat. Type countdown in the chat if you got these same exact numbers here on the screen on your calculator there. Type out countdown in the chat if you have these numbers. Your numbers are off. Okay, that's why we go ahead and take a look here. Let's look at our numbers here once again. All right, Bill. Let's take a look here at your numbers. Your numbers should be exactly what you see here on my screen. So make sure they match up. And let me know once you have those all set in stone. Let me know once you got all your numbers there, so that way you have it matched up. So that would be the problem. All right, let's change that to 35. Change that second one to 35, and then hit second in mode. And then let's go through the process here one more time. And let's hit stat, go to calc, linreg ax plus b. Again, hit calculate. If you have the old school calculator, Make sure you have L1, comma L2. Okay. All right, let's see if we get the same numbers here. If you have the old school calculator, this is what it should look like for you, Bill. Or again, if you have the new school, you could just go to calculate here. And let me know if you got the same exact numbers there, Bill. All right, beautiful. Okay, so let's take a good look here. Now that everybody's numbers match, let's take a good look here at our results for what we need. Okay, so we're gonna answer a lot of questions in relation to this, I promise you. All right, but first and foremost, we're gonna take a look at these first two numbers here. As you can see, on the calculator, this says y equals ax plus b. Now, a is going to be your slope. Okay, so a is going to be your slope, which is going to be minus 0.0479. Okay, so you're going to have minus 0.0479x. And then you'll have the y-intercept here again, 69, nicely said, 0.296. So this is going to effectively be our line of best fit. Okay, so minus 0.0479x plus 69.0296. Okay. Before we move forward here, any questions so far? Any questions so far, you guys? Nope. Alright, nope. Good stuff. As long as we're all on the same page, I'm very, very happy. Alright. Savage P! Alright. No questions. Alright. Alright, we're good so far. Now, let's talk about letter B. Now, one thing that's going to be asked of you on the homework and on the test is going to be asking you, saying, hey, can you tell me how to interpret the slope and the y-intercept, if appropriate? Okay, so that's what question B is asking us here. Now, let's talk about the slope first and foremost. Now, the slope here, the number for the slope, we already know what the slope is. All right? So the slope is this guy right here, this minus 0.0479. However, let's remember that the slope here reflects the rate of change, and we want to be able to reflect that using the context that we're given here in this particular question. All right? So basically, here's how it works. Since this is the context of x here reflects the commute time, it says, basically it says this. Here's the interpretation for the slope. For every minute of commute time, I can't spell, but that's okay. For every minute of commute time, the index, what is this, the well-being index, decreases by 0.0479. Alright, so basically, I said, we say decrease here because of the fact that, again, this is a negative here, okay, and it decreases by a 0.0479 here. So, again, I just took the context here. For every minute of commute time, the well-being index decreases by whatever that amount is in this case. Now, if this was positive, I would say increases by 0.0479. If it was positive, in this case, it happens to be negative, so hence it decreases. Okay? So that's how we can interpret the slope. Okay? So we'll ask you for a question like that. Now, here's the other half of this question. There's one more half of this question here for letter B. This talks about interpreting the y-intercept. Now let's talk about the Y-intercept here, because it's a little bit more interesting for a different reason. Now, of course, as we can clearly see, the Y-intercept is the 69.0296. However, in this case, let's talk about this for a second. In this case, it is not appropriate to interpret the Y-intercept. Okay? It is not appropriate to interpret. Now, of course, we have to explain why. So let's explain why it's not appropriate here. It seems a little strange to say that, but it is not appropriate. Now, the reason is because 0, remember how it works for a Y-intercept, okay? In a Y-intercept case, this always reflects if x is equal to 0, okay? That's what a Y-intercept means. If x is equal to 0, then technically we should have a value of 69.0296. But the problem is that 0 is not within the context of the problem itself. 0 is not within the range of the commute times. All right, so this is the biggest reason why, and this is very important to know. Again, this is because 0 is not in the range of commute times. Remember, the range of commute times here is between 5 and 105. Okay, so between 5 minutes and 105 minutes is the range of commute times here that we have. So 0 is not in that range, so therefore 0 doesn't really mean anything since it doesn't really exist in the table whatsoever. So you have to just kind of look at the table, and if 0 is not included in that, then it's not appropriate. If 0 is included in that, if a 0 is in that range, you know, you could have, say, -4 to +5 or whatever, then yeah, 0 is just fine. 0 is between, say, -4 and -5. Okay, that's fine. But it's not, in this case, it's not in the range here. Again, it's not between 5 and 105, so you're out of luck. All right? So that's why, in this case, the Y-intercept is not appropriate here in this instance. Okay. So we have that. All right, questions about that so far? Nope. All right. Be answering several questions here, so this I promise you.
What if I go stronger? What if I get higher? What if I
Okay.
keep doing things I know?
Let's focus on letter C now. Predict the well-being index of a person whose commute is 30 minutes. Okay, this one is really, really simple. All you have to do for letter C is all you need to do is plug in 30 into your line of best fit. That's all you need to do. So what we're going to do is we're going to have y is equal to -0.0479. We'll plug in 30 in for x, and then we'll add that to 69.0296. I'll put this on the right here now. Actually, no, I'll leave it here. All right, so let's take out our calculator here. All right, let's go ahead and figure this out here really quick. So we'll have negative 0.0479. Multiply that by 30. And add 69.0296. So here we get 67.5926. Okay, there we go. And so that's how we can go ahead and find out letter C. It's very simple. They say, hey, Tell me what it is after 30 minutes. Use the line of best fit, and you should be right there. Okay. So that one there, very simple. Let's look at letter D. Okay, letter D. This shouldn't be too hard, but let's take a look here. Couple things we'll need to talk about this one. Okay. So letter D says, suppose Barbara has a 20-minute commute and scores 67.3 on the survey. Is Barbara more well off than the typical individual who has a 20-minute commute? Okay. So for this particular problem, if you see a problem like this on the homework or on the test, then what we want to specifically do is we first want to go ahead and see, we have Barbara here who scored a 67.3. Okay, fine. That was her score. But let's see what the model would have to say. Again, the line of best fit here that we found here in part A is the model that we can go after, okay? So underneath these, underneath the average conditions here, what would we get if we had a regular 20-minute commute with, let's say, anyone? So let's plug in 20 here first and foremost. Okay. And let's see what we get here in this case. So we have, again, I just plug it in x equal to 20. So can anybody give me an answer for this here? So does anybody have the answer for this? Negative 0.0479 times 20 plus 69.0296. Does anybody have an answer for me here? Let's see what numerical answer we got here. I'll have one of you guys tell me. $68.08. I can't say that. 68.0716. Okay. Good. Nice job, everyone. I'm like trying to say it. I'm like, ah. All right. Okay, so let's take that answer that all of you found, and let's compare it to Barbara, okay? Because she has a 20-minute commute, and she scored 67.3. So, is Barbara better or worse? Would Barbara be better than the model or worse than the model? What do you guys think? Worse. All right, so that part is definitely true. Barbara is worse off. Okay, so she scored worse than the 68. So ideally, she would score 68.0716. That's her ideal score, but clearly she is less than that. So she's worse off, not actually better off. All right, so yeah, it's either unfortunate, but that is what it is. It's ironic because the first class said all better off for some reason. I don't know why. But anyway. Okay. Very, very good. All right. Any questions about that? That should be pretty simple. All right. Okay. Now, the next thing I want to talk about here specifically, I do want to talk about something here specifically. Let's discuss this. All right, and that has stuff to do with, it's not a question on here, but let's say I want to see how good the model is in comparison to the real data that I have here on the table. So I want to compare, say, hey, let me compare data items in the data set and compare it from what my raw data says and compare it to what the model says, okay, my line of best fit. So what we do here is, in order to make that comparison, we use a concept here. Let's take a look at that. We talk about what's referred to as the residual of a data item. We talk about the residual of the data item. So what is the residual here? Residual is very, very simple. Residual basically is the observed value minus the modeled value. Again, the model value using the line of best fit. So let's say, for example here, let's go back to our paint tool here. let's say I wanted to find the residual here. Let's go with the residual. Again, that's observed minus model. Now let's say I picked a data item here. Let's say specifically I picked the data item here of x is equal to 25. Okay, and I want to find the residual of x is equal to 25. All right, so the way I want to do that here is I take a look at the value of x at x is equal to 25. So the observed value at x is equal to 25 is this y value here of 67.5. So that's 67.5 here for my observed value when x is equal to 25 according to my chart. Now I'm going to subtract that by the model when x is equal to 25 by putting in 25 into my line of best fit. Let's figure that out right now. So let's say again, let's put 25 into our line of best fit for the model. So let's go with the minus 0.0479 times 25 plus 69.092 x. Oh, 0296. Sorry, I put that the wrong way. 0296. My bad on that. Okay, and can anybody give me an answer for this? Anybody give me an answer for the model here in this case? 67.8321, okay? All right, very good. So we're going to put that right here. All right, so that's going to be our model value right here. So that's why I do 67.5 minus 67.8321. Now what I would like you to do is let's figure out what the residual is. What's this, when we subtract these, what is the residual? So what is the residual here? Go ahead and do 67.5 minus 67.8321. What is that value going to be? What's that difference going to be? All right. Minus 0.3321. All right. Very good. Okay, so what does this mean here at the end of the day? If we take a look at this residual, this basically means that the model, the line of best fit, overestimates. Again, 67.8321 is bigger than 67.5. So this overestimates by 0.3321, all right, in terms of on the index here. So it overestimates by just a little bit. All right, so effectively, how would this look like here if you were looking at it from a pictorial perspective? So the pictorial perspective here actually is fairly helpful. So what would it look like here? Essentially, here's what it looks like. If you have, like, say, let's say this is the scatter plot, for example. And we have, let's say this is the point here. Let's say this is the y value of 67.5, okay? So this is our actual data item. The line of best fit here is, let's say, somewhere above here. And let's say this point right here, and I know this doesn't make much sense, but still, it helps. Again, I just a crude representation here. So, and here we have 67.8321 is up here. So we're just going to take a look here at this difference right here. All right, like I said, I know this is a very crude picture, but it gets the point across, at least pictorially. That's what we're looking at here. Here's the model up here. here's the actual value down here, and this part here, this line between both of these points is the residual between both of them, and that's essentially how we want to look at things when we talk about the residual. So this line could be above that point, it could be below that point again, just depends at the end of the day. This is just with a crude picture here. So that's effectively how residuals work in a nutshell. All right. Okay. Very good, very good. Any questions so far? Any questions? Any questions about that? No? All right. Hopefully it's easy so far. If you have questions, just let me know. All right. Nope. All right. Okay. Now I do have one more question for you, and hopefully you remember from what I talked about before here today. That is here in 19G. Let's talk about this here. This is another question that you will see on the homework here. Again, it's not really expressly asked in the previous question, so I'm going over 19G here. Let me go ahead and make this a bit bigger here. Here we go. 19G. Would it be reasonable to use the least squares regression line, i.e. the line of best fit, to predict the head circumference of a child who was 32 inches tall? So would it be reasonable to use, so this is basically saying, would it be reasonable to use the line of best fit to predict the head circumference of some child who was 32 inches tall? This is a simple yes or no question here for part G. So yes or no for part G. 19G. Let me do this. I'll zoom out here a little bit so it's all on screen. Okay, what do you guys think? Yes or no, would it be reasonable to use the line of best fit for a 32-inch tall child in this for this table here in part G? For part G. Yes or no, and then why? If it's yes, tell me why. If it's no, tell me why. I'm just taking a guess if you're not sure, but I just want to see what you guys think. That's all. Yes is my guess. All right, let's see what other guesses are. That's fine. About... All right, Sammy says no. All right. Let's see what Maritza and Bill have to guess. All right, Maritza guesses yes. What about Bill? What does Bill think? Yes or no? All right, Bill guesses no. All right. Now, one of those two answers, of course, is correct, naturally. All right, let's go over the answer for this here specifically. The answer for 19G here is going to be no. The answer here is going to be no. Now, let's explain why it will be no, as opposed to being yes. This is going to go back to what I talked about earlier here today. Remember, as I talked about here, I said... Remember how I said for the Y-intercept it wasn't appropriate to interpret because 0 is not in the range of the commute times or the x values here? Well, let's take a good look here. It says, okay, I want to figure out the head circumference of a child who's 32 inches tall. Well, can you guys tell me what's the lowest x value and what's the highest x value? What's the lowest x value and what's the highest x value in this chart? Can you guys tell me here? What's the lowest x value and what's the highest x value in this chart that you see here on this page? Just take a look at the table here. What's the lowest x? Okay, so the lowest here, 24.5. And, Strolling, the lowest x value and the highest x value. They both need to be x values. Both x values. Maritza says 24.5 and 27.75. That's right. Alright, so 24.5 is our lowest x value. And 27.75 is our highest x value there. Alright, so our range for our x values are from 24.5 to 27.5, or 27.75, excuse me. So 32, just like 0 was outside of our range, 32 is also outside of the range from the lowest to the highest here in our table. So I'll put a little note here for you guys, and that says this. If the value in question is not in between the lowest and highest x values, then it is not appropriate to use the line of best fit. So in this case, again, if 32 is not appropriate to use because 32 is not in between 24.5 and 27.75. If we had, say, 24.5 to 33, sure, 32 is fine. We can use the line of best fit. That's fine to use the model there. But in our case, it is not okay to use because of the range of the x values that we're given here right off the bat. Okay, so the answer to this question here is going to be a big fat no. All right? Okay, any questions about that? Okay, any, hopefully that was pretty easy. Any questions about this section? These are all the questions that will cover everything you need to know for section 4.2. There's really not a lot in here, but again, all the questions of every single one will cover pretty much every single one of these questions here from this one example covers pretty much everything for this particular section. So, should be in good shape. All right. Very good. All right. Very nice job, everybody. That's all I got for you today. So that's it. There you go. It's just that easy, folks. It's just that easy. I know. That's it. We're done. Yay, yay. You guys thought, man, you're like, yeah, that's it. That's section 4.2. Ba-boom. Got it. Next time, ladies and gentlemen, section 4.3. And we'll get that knocked out of the park. Maybe we'll do both sections. Who knows? Whatever. We got lots of time to work on that, so that's just fine. That's just fine. You guys are doing absolutely fantastic, so I'm really happy to see the progress. Really happy to see the progress, 100%. Now let me switch over the camera. Alright, I want to thank everybody for coming on out here to the stream once again. All of you are absolutely fantastic. I love you all. All of you have done a wonderful job here up so far. Again, we'll finish up section 4.3 on Thursday. We'll come back here 48 hours from now, okay? Or a little bit less than that, of course. Same time, same place. You guys know where to find me. Again, you can find me on Discord. You can find me wherever you need to be. That's perfectly fine. But I'm going to tell you guys one thing right now. Something that I said in the first class, but something that you also need to know. I'm going to leave you on a cliffhanger here today. I may make a big announcement next Tuesday. Make a big announcement here next Tuesday. Okay, so be on the lookout. I'm going to have possibly a very large announcement here on Tuesday. Okay, so need to get through the material first before I can make that said announcement, but I'm going to have possibly a very big announcement here next week. So, yes. So I'm going to kind of leave you hanging here for a week. I'm still kind of mulling over it a little bit, but once I feel I want to finalize it, which I'm leaning toward doing, then I will make that formal announcement. And I'll send it on emails and do all that stuff. But yes. That is the story moving forward. Okay? Alright, everybody. I'm going to leave you on this cliffhanger for a week. Meanwhile. Alright. Alright, everybody. Thank you so much. As always, everybody, have a wonderful evening, everybody. Take care of yourselves. And as always, everybody, stay safe, stay healthy. But most importantly, stay sane. Alright, have yourself a wonderful night, everyone. Take it easy, everyone. And we'll see you in a couple of days. All right, thank you guys for coming out every single class. You guys definitely make this last class worth it, because you guys always show up, you guys, and I appreciate that very much. I really sincerely appreciate that very much. All right, thank you guys. You guys are wonderful. Have a good night. Thank you, Bill. Have a good night. Sammy, good night. Maritza, good night. Strolling, good night. Take care of yourselves. We'll see you in a couple days, everybody. Take care of yourselves, everybody. We'll see you. All right, everybody, take care. Bye. Bye, everybody.